70s this technology started to show up, and by 80s it was reasonably mature, and today majority of databases are managed through SQL. But as it started to become popular, people tried to store geographic data, satellite imagery and maps in SQL products. And they again had same kind of challenges that we saw in case of statistics. Okay? So if you try to store geographic data in relational databases, at least pure relational databases, it's not easy. And there were a lot of discussions and so on. But mid-90s people found a way to find a middle ground, and that's what we are summarizing next. Okay. So there are many queries which are geographic in nature. In location-based queries, you saw that. In addition, there are some very simple queries like geocoding. So given a particular street address, you want to know latitude, longitude, right, or vice versa. When people geotag a picture, right, then you are again based on GPS coordinate, you might want to know the place names. Okay. We talked about geofencing, where you draw a boundary, and if a particular object crosses the boundary, we want to know when that happens. These are all simple examples of spatial querying. And it turns out that in order to do this, you need some new spatial data types, which original relational databases did not have. But now there is this standard, and this is the basic thing I want to at least all of us to remember. There is a standard called OGC simple feature types, and there is an equivalent standard in ISO. This standard came about mid-1990s, and today it's used widely. So if you are using software like Postgres SQL, how many of us use? Quite a few. Okay. It complies with that, or Oracle Spatial and so on, they all comply. So in order to represent these kind of queries, they have added 6 data types. Okay. So one is very simple, point. Like GPS, when you see the center, lat long is a point. Right? They have a line string, and this may represent center line of a road. So essentially this is a sequence of straight lines. Okay, so that's what is a line string. And then finally polygon, where this kind of closes. So these are 3 basic types. Easiest way to remember them is this is in 0 dimension, 1 dimension and 2 dimension. Okay. But in addition to that, they also added collections. And this reasoning is a little bit non-intuitive. So, but you can see natural use cases. So multi-polygon you might use to represent a island nation like Japan. So as we know, Japan you can't model as a single polygon, right? It's at least 4 major islands. So that could be a collection of polygons. Even India, it's not a single polygon, right? Because you have many islands in India and so on. And same way, if you have a collection of oil wells, you might use that. But in addition to that, this allows us, what is called a closure operation. So for example, you can have just 2 polygons, and when you take a difference, the result may not be a polygon, it may be a multi-polygon. Okay? So having these 6 types allows you to create what will be mathematically or algebraically called a closure property, and it allows you to have multi-step queries. Okay? But this is widely used. And in addition to these 6 types, they also added many operations. So you can have topological operations. So you can ask, for example, whether a point is inside a polygon. So you could essentially write a query saying, give me every school which is inside the boundary of Delhi. Right? Delhi is a polygon, schools are point, and you can write those queries. You can do distance, area, and a lot of your intuitive predicates are all standardized here. Now, tomorrow, we will actually go and try to mathematically, give you a more rigorous definition of this, because the actual rigorous meaning of some of these things are slightly different than dictionary meaning. Okay? And I'll give you a quick example for now, but maybe tomorrow we'll see mathematically why that's the case. So I'll just draw the map of Vatican City and Italy a quick minute. That's it. It's a very approximate map. So, some of you might have seen this map, the peninsula of Italy. There is city of Rome, and inside Rome there is a little area which is controlled by Vatican, right? So if I ask you about the relationship between Vatican and Italy, spatial relationship, okay, spatial relationship, how many of us will think that Vatican is inside Italy? A couple of us, right? Yeah. But in this definition, that's not going to be correct, okay? Because in alright, in OGIS, you can say that Delhi is inside India, and that is correct because the interior of Delhi is also interior of India, okay? But in this case, the interior of Vatican is not interior of Italy because Vatican has its own government and its own police. The Italian cannot just go to Vatican and arrest somebody, right? So Vatican is a separate country, so to say. Right? So in this case, actually, Vatican is a neighbor of Italy. Okay. So there are some subtleties. If you use your English meaning with these, you will be there 90% of the time, but occasionally it will surprise you. So, by tomorrow we'll give you a mathematically rigorous definition of what these things mean. Okay. So in order for us to express spatial queries, relational databases had to add new data types, new operations. Without that it was very tedious, and I will also show you an example tomorrow how painful it was without these. Okay? And in addition, there was a performance issue. So if you actually think about relational databases, they have certain data structures to speed up the queries. So some of you probably remember indexing methods. Can anyone name a popular indexing method in relational databases? B tree, B plus tree, hash table, people remember those? Okay. Now those are not sufficient to speed up spatial queries, okay? Because they all make a very simple assumption. For B tree, your keys have to be something that can be sorted, right? Like numbers or strings, you have a strict ordering. But if I'm looking at points in 2 dimensions, right? Latitude, longitude of every city in India, is there a unique sorting order? There is not, right? You could try to sort it by either latitude or longitude, but it's not going to preserve proximity relationship. So in addition to having new data types, they also had to add new indexing methods, and some of you might actually know the name. A popular one is called R-tree, okay, which is supported by many of these software like certainly Oracle, Postgres, and so on. And this R-tree sort of looks like a hierarchical collection of rectangles. Okay? So it's a generalization of B-tree. B-tree is a hierarchical collection of intervals in 1 dimension. Here it's hierarchical collection of rectangles. So you notice that these 3 rectangles are inside rectangle A. So A is children are down here. Okay, these red ones are the children. Same way B is parent of these ones and so on. Okay. So it's a 2-dimensional structure. Actually, you can use it in 3 or 4 dimensions as well. So spatial databases added new data types and they added new data structures. So data types made it easier to write the query. Data structures made it fast to execute the query. Okay. So these are 2 core notions, and we'll get a sense of this tomorrow. We'll certainly be writing some SQL queries using these types and these operations. And time permitting, I will briefly tell you about some, a little bit about R-tree as well. Okay. Alright, now, I will come back to this privacy question. This database technology has been very successful, right? We have databases like Microsoft Access on any PC. Even on your smartphone, you have little databases and so on, right? We use it so much. And so now the question in databases, not too often database researchers here, but there are technical questions, but the bigger question has shifted to the social part. Databases have made it so easy to collect information that now we are worried that we are collecting too much information, okay, and we are violating privacy. And this is showing up again and again and again. And a lot of this, previously was inconvenience. If you are worried about identity theft and things, credit card information being stolen from a database, those things are inconveniences, but not as bad as what happens when geographic data is stolen. Okay, so here is one example which comes from Defense Department. So US Army actually has a very simple training manual. Every soldier is told, be careful about geotagging. How many of us know what is geotagging? Okay, great. Can one of us share what is geotagging? Just give an example or tell everyone what is geotagging. Okay, so when you post a picture and so on, you can put a location, right? Okay. So, yeah. So can you guess why US militaries, every soldier during their training, they are told not to geotag their pictures? What could be the reason? Basic training manual. This should be, every teenager should be made aware of this. Most soldiers are teenagers, as you know, right? If they go after high school.
Military position will be traced. Military location and positions will be traced by the other person.
Okay, perfect. Because if they are doing that, they are revealing to the adversary where they have been. Okay, and there is a very good reason for this. Okay, this is the manual from there. And as you know, if you take pictures from your camera, it automatically can put the GPS coordinate in the picture. You don't even have to say that, right? Unless you go and switch off your location services and tell it's not to be used. So inadvertently, you can just